Alright, so in this section we're going to talk about gamma and linear workflow in Redshift. So the idea here is that we want our calculations to be made in Redshift in a linear color profile without the sRGB gamma correction that we will apply post-render. And the reason we want all of our values to be linear is that when we start adding values together, we want them to add together in a linear way. So for example, 0.5 plus 0.5 should equal 1. So Redshift does a pretty good job at taking care of a lot of that for you, up to the point where it will make assumptions based off of the type of image textures you're piping into your materials. For example, things like JPEG and PNG, Redshift will automatically assume is in sRGB color space and will convert to linear for you. Whereas something like an EXR image, it's going to assume that it is already in linear color space and doesn't need any conversion. Now, unfortunately, I wish I could say that it was as simple as that, and that's all you need to know, but that's simply not the case. And the two biggest outliers are when dealing with color swatches and when piping textures into data inputs. So let's actually start off with color swatches. Go ahead and pipe a material out to our surface. And this is just a standard material. So when we look at our color swatch, immediately we're actually going to notice that this color swatch is in a sRGB profile. So when we enter 50% into this color swatch, it's actually not 50% gray. If we wanted to get 50% gray, we'd actually need to enter 72%. So that's just something to consider when dealing with color swatches in your materials. Now the other place you'll run into it are in things like a ramp. For example, if we take a ramp and look at its color swatch, we're going to see that that is also in sRGB color space. So for example, if I was using my ramp to control reflection roughness, and I set my ramp to 50%, you're going to see that my roughness value differs from if I actually went into the shader and enter 0.5. So in order to compensate for that, the easiest way is to simply add a color correct after your ramp and then pipe the color correct into your data input. And then from there, add a 2.2 gamma, and you'll see now that our 50% gray equals the same value as our 0.5. And this actually goes for image textures as well. So I've got this wrinkly image texture, and I'd like to use it as my roughness. So if I take my image texture, go into reflection, and enter reflection roughness, you'll see that we look kind of strangely clamped, and that's because we are going to need to convert our image to linear. And we can do that in a couple of places, but usually for visibility's sake, I actually like to keep a color correct node out in the scene rather than changing my gamma override in the texture, because then it's just very visible what's going on. So now if we pipe our image texture through our 2.2 roughness, you'll see now we get the variation in our roughness that we were expecting. Now, that's not to say that it's incorrect to build your materials using an sRGB profile for data passes or for data inputs. But if you're getting, for example, pre-made materials that have specific values in mind, you're going to want to convert any image texture going into a data value. And just to explain what I mean by that, the color inputs, for example, diffuse color, are actually expecting an sRGB color input. So in this case, we don't actually need to correct for anything. And this is again why using a color correct node for our gamma conversions can be very useful, because we can use our sRGB image directly into our diffuse color, for example, and then use our gamma corrected version to drive something like roughness. Now, it's not particularly flattering in this image here, but I definitely think that it's good to know about. A good general rule of thumb, if you're ever wondering if you should be converting your images or not, are really quickly ask yourself what the image is being used for. If it's being used for diffuse color, for example, or reflection color, anything with the word color in it, you do not need to make that conversion. However, if it's some other value that doesn't have a color swatch in the material, you should put a gamma correct after it. You should insert a gamma correct in there to get the result that was initially intended by the image creator. Now again, it's not inherently wrong to skip this step. However, you are going to get different results than were intended by the creator of the image. And if that person happens to be you, well then, more power to you. By all means, use the method that's going to work to get the look you need. And if that includes skipping a color correct on data, then you do you. All right, well, thanks for checking out the section on linear workflow and gamma correction. We'll see you in the next one.